we are going to look at adding and subtracting polynomials in this video. Now, of course, a polynomial, it is a function with the form such that all the variables have positive exponents and integer exponents. So an example could be 2x squared plus 3x minus 5. And that's what I call a polynomial. And we're going to look at adding that with another polynomial. Maybe I could label it g of x, and I say that's x plus 3x squared plus 7. I write it that way because I'm going to emphasize something in a second. But we're going to look at adding those two, maybe subtracting it. So that would be f of x plus g of x. So add those two polynomials. Or maybe I want to call it f of x minus g of x if I'm subtracting them. Except we're going to look at it in a very basic way, and we're kind of not even going to really worry about our function notation here. And we're just going to be given our two polynomials, add and subtract them. And we're going to see it comes out real nicely and simply, and all we have to do is basically combine like terms when we do it. Once we get our answer, we're going to want to make sure it's in standard form though. A standard form is when the terms of a polynomial are in order from greatest to least degree. So I wrote those two polynomials below two different ways for a purpose. First one, f of x. This guy is in standard form. Check. This one, g of x, is not in standard form. It's not in standard form because the x is first and the x squared is second. To put this in standard form, it would be 3x squared plus x plus 7. And when you're dealing with polynomials, it's always a good habit to write your final answer in standard form. It's just easier to read and kind of interpret and classify that way. Find the sum and write the answer in standard form. Now, you see how we're doing it the basic way. I'm just given two polynomials here. This one and this one. They're two different polynomials, but we're hardly even worrying about function notation of f of x, g of x. And we're just told, let's add them. And as I said, it boils down to just combining like terms. We know that I can only add two things that are similar, so the x squareds together. And then when I add them together, I get 3x squared, because I have 2x squared plus 1x squared. I move on to the x's. I have 1x plus 1x gives me 2x. And then I can go with the constants, that is the numbers without a variable, negative 5 and 6. Negative 5 plus 6 gives me a positive 1. And there's my two polynomials added together. And I check it's in standard form. It goes from x squared to x to no x. So the powers of my exponents go from greatest to least. Okay? Try another one. I can add three polynomials at one time. Same idea holds though. I just look through all of them and combine all like terms. I notice an x cubed, so that's my highest power. I'll start with that. And none in the middle one. Now notice how I'm circling the sign in front with it. Because when I'm adding, I want to bring that sign along with it. Because this x cubed at the end here, it's negative 1x cubed. It's not just 1x cubed, but then negative with it. So when I combine them together, I have 5 minus 1, or 4x cubed. Alright, moving on to the x squared. Here's 1, here's 2, here's 3. So I've got 2 plus 3 plus 4 gives me 9. So I have 9x squared. Next term down, the x's. So I have minus x, another one here. Negative 1 plus negative 4, that would be negative 5x. And then my constants. I get a plus 7, a plus 7, and a minus 8. So 7 plus 7 is 14, minus 8 would be 6. And here's my final answer. It is in standard form once again. I go 3, 2, 1, 0 as far as the exponents. So it goes from greatest to least. So it's written in standard form. And I have combined all like terms. Each of my powers appears only once, so there's no more like terms to combine. Thus I know it's in its simplest form and done. Now that we've tried 2 where it's just adding, let's try subtracting. Again, combine like terms. Same things with same things, combine them. But the first thing I want to do is distribute this negative to each term in the second polynomial. That way I won't get confused later on. Because what am I doing? I'm taking this polynomial and subtracting all of this polynomial. And if I'm subtracting all of that polynomial, I'm subtracting each bit inside the polynomial. So that minus sign right here needs to apply to everything in that polynomial. All right, let's get some of that out of the way. And back to what I said about distributing this negative to each term first. So I'm going to rewrite this as 2x squared plus x minus 5 minus 3x squared plus 5x minus 9. Once I distribute that negative, I can just go ahead and combine like terms just as I did in the previous example. So I got my x squareds. 2 minus 3 gives me a negative 1x squared. A 1x plus a 5x gives me 6x. And then finally a negative 5 plus a negative 9. Negative 5 minus 9 will give me negative 14. Polynomial in standard form, check. Important thing there, distribute the negative first. Let's practice that again on one final example. Here we have a combination of both subtraction and addition. Just remember, let's move left to right, combine like terms, and it all kind of plays out the same. Oh, also our variable is now p. Doesn't matter, p, x, they're all variables. They all kind of behave the same way. So the first thing I'm going to do is rewrite this. However, I'm going to distribute that negative in this second guy. So I have negative 3p squared minus 2 plus 9p. That way I won't get tripped up and maybe forget to subtract one portion of that polynomial, but I will be sure to subtract all of it. Working through here now, let's look at our like terms. The p cubed, got only one of them, so 4p cubed. P squareds, I got a negative 3p squared plus a 2p squared. Negative 3 plus 2 gives me negative 1p squared. The 1 is implied, so I don't necessarily have to write it. Going down to the p's, 7p plus 9p plus 3. 7 plus 9, 16, plus 3, 19. Got a lot of p's there, 19 of them. Finally, I've got my negative 8, negative 2, and 4. Negative 8 minus 2 is negative 10, plus 4. So I'm going from negative 10, more positive, negative 6. Is it in standard form? You bet it is. It goes from greatest to least degree. So there's my polynomial. Added and subtracted and simplified.